Okay, so after layer recap, let's look at an example for a chi-square goodness of fit test. So lana sobe sisenza it to test whether this given set of data follows a Poisson distribution. Yabo. So city. So it statements read as follows. As a corner with description is it's let's x denotes the number. Oh, let's x denotes the repair times in the number of days required for a certain component in an airplane. We wish to test whether a Poisson model with a mean of 3 days, so we were given one parameter mu is equals to 3, appears to be a reasonable model for this variable. The repair of 40 components were recorded with the results shown in the table. In some cases, the components could be repaired immediately on site, which is interpreted as 0 days. Yeah, well, so we see a test at 10% level significance. Its alpha is equivalent to 0.1. Yeah. So before sending the ning, we should do a null and alternative hypothesis. Yeah. For our null hypothesis, H naught is so this formula and a statement would say OX, which was the variable which denoted the number of the repair times. So X follows a Poisson distribution with a mini L3. Yeah, so X follow X low Poisson distribution with a mini L3 is an appropriate. This is supposed to be appropriate model. And then for alternative hypothesis, the X or Poisson distribution with the mean of 3 is not an appropriate model. So scenario parameter which means we did not have to estimate anything did not have to estimate anything. That means M2 uzoba 0, M2 uzoba 0, and then mase sengiphume kanje la sengifuna uthola ama probabilities. Sengifuna uthola my probabilities. So ngiqala nge-probability that x is equals to 0. So according to EPMF, it is e to the power of negative lambda times lambda to the power of x divided by x factorial. So last one e to the power of negative, it was 3 so to the power of negative 3 times 3 to the power of 0 divided by 0 factorial. I'll open my calculator. So it says e to the power of minus 3 times 3 to the power of 0 divided by 0 factorial. 0 factorial is 1. So a probability alana is 0,0498. 0,0498. Now I'm going to see round off to 3 decimal places. So 0,0498 so 0,050. 0,050. And then elandelayo kuzobe sengithi ngibheka le yaka 1, so x ushintsha bo 1 nalo kubo 1, fake 1 la 1 la, so kuzoba 0,149. Elandelayo u2 noshintsha lapha na u2 kubo 2. Let's make a probability of 0,224. And then same thing, let's say 3 3 nakhona 0,224 naku-10 kuzoqhubeka naku-4 uzoba u-0,168 for 5 0,101 for 6 should be 0,050 and for greater or equals to 7 ikanjena ke impahla le since it is discrete a probability that x is greater or equals to 7 iyafana no 1 minus the probability that x is less than or equals to 6 yabo it's discrete u7 vele ngosingi-include ngapha angimele ngim-include ngale yabo noma ngithi kanje my value 0 1 2 3 4 5 6 7 8 9 up until ngale so the probability that x is greater or equals to 7 ilama values lawa ngithi so lama values lawa up until i-value yokugcina ngifuna ukuthi ngifuna ukuba nayo yabo ukuze ngisayile na lama values kumele ngiminus lawa i-probability yawo wonke lama values lawa esewonke u1 angithi and to get lawa ngali greater or equals to 7 ngizomele ngenze njani remove lawa are less than or equals to 6 that's why ngithi 1 minus the probability that x is less than or equals to 6 a probability that x is less than or equals to 6 is the sum of wonke lama probabilities from 0 up until 6 so 0,05 plus 0,149 plus 0,224 plus 0,224 plus 0,168 plus 0,101 plus 0,05 that's 1 minus the answer I'll get a probability elingana no 0,034 nabo sengina wonke ama probabilities sengifuna ucalculate my expected yabo manje into bengiyaziyo mina ngiyazi ukuthi u-n wami it is equal to 40 because the test le bayenze for 40 days or I can also check it la isum la u40 which will give me u-n or another check kumele siyenze more add lama values lawa should give you a probability a1 yabo okay asicalculate ama expected day so expected yala yokuqala kuzoba u40 times 0,05 so 40 times 0,05 will give us expected u2 ne masingisa ku 40 times 0,149 I get the answer u5,96 40 times 0,224 is 8,96 nale is 8,96 8,96 times 0,168 6,72 4,04 2 1,36 and then manga add number value lawa should give me 40 then kube khona something nyana angithakhumbula ukuthi besifuna ukuthi ama expected weights they should all wonke kumele abe greater or equal to 5 but they should be greater or equal to 5 so ngizobheka ke mina laba bangahlangene laba bangalingani no5 nangulo akalingani no5 nangulo noma ngithi mancane kuno5 labo yabo so laba bancane into engizoyenza kuzomela ngibahlanganise yabo I mean ngizomela ngihlanganise laba balandelanayo so lo nalo ngiyabahlanganisa 4 plus 2 izoba right manje uzoshuta lozomela laba kuzomela ngibahlanganise bonke ukuze babe right yabo so ama classes zami manje ashintshile from u8 asewu this is 1 2 3 4 5 asewu 5 manje ama classes zami yabo so siba edile laba saba eta laba, saba eta laba, saba eta laba. So 2 plus 5,9, 2 plus 5,96 gives me an answer ka 7,96, and then 4,04 plus 2 plus 1,36 gives me an answer 7,4, 7.4. Nalaba 7 plus 6 plus 0, 13. 1 plus 3 now makes 4. Yabo. Hey, you can see right here, manje. I can go ahead and calculate my test statistic. The test statistic chi-square naught is equal to the sum of observed minus expected squared divided by expected. Yabo, so it's a fine, you can see. So qala la angeke ngisathi 1 minus 2, sengizothi 4 minus 7,96 squared divided by 7,96 plus ngizobe sengi-add nalaba so 7 minus 8,96, so 7.4, so 7 minus 8.96 squared divided by 8.96. So uzokwenza kanje up until uzofika on the last class lokugcina yilo leli, yabo, up until uzofika kulona, yabo. Once uswenzile ke lawa masamu, you will have a test statistic elingana no 9,22, yabo. So it test statistic is equal to 9,22, and after calculating our test statistic, we want to calculate our critical value. Yabo. Critical value yethu lingana no chi square with k minus 1 degrees of freedom and or alpha. K it represents the number of classes after adjusting. Yabo. So after adjusting, our classes same ngaki 1, 2, 3, 4, 5. Yabo. So it's 5 minus 1, so chi square with 4 degrees of freedom and alpha, which we're testing at 10%, so it's about 0,1. Le value lena a critical value too. It is it's k minus 1 minus m. No, alpha or m represented the number of estimated parameters, and we are completely in the beginning of the video and say there were no parameters as well estimators nikeziwe a parameter sidingayo a mean, yabo. So 4 1 7 critical value 7,779, yabo. And yabona ukuthi le value le inkulu kune critical value. Our test statistic is greater than a critical value, yabo. So since ke chi-square naught is greater than 7,779, sinasenjani h naught is rejected at 5% level of significance. If h naught is rejected, kusho ukuthi le data leli esilcollectile does not follow the specific distribution ebese test, yabo kahle. Le data does not follow a Poisson distribution. Noma ngamanye amazwi ngizothi x, which was a poi with a mean L3, is not an appropriate model. This is the test. This is the test, and then you may want to calculate this using a p-value method. Using a p-value method, a p-value la it is equal to a probability that chi-square is greater than chi-square naught, which is a test statistic. So it is the probability that chi-square is greater than 9,22. Yeah. So 9,22 na akekho exactly kuma tables, mara siyazi ukuthi chi-square abo 9,22 is in between some values. Angenze kanje. Can I just open my statistical tables? Okay, so singavulile ngizwa kwi-chi-square ngeke-degrees of freedom lawa awu-4 ebengwacalculate ekuqaleni. 4 degrees of freedom 9.22 angaba in between 7.779 kanye no 9.488 ne 7.779 corresponda no 0.1 yabo, and le 9.488 corresponda no 0.05 ne kusho ukuthi i-p-value is in between number probabilities lawo, so it is greater than 0.05 but less than 0.1. This is a p-value yethu yabo, and since a p-value is less than 0.1 yakhumbula ukuthi 0.1 was our level of significance, kusho ukuthi u-h naught nala still siyam-rejecta, meaning we have sufficient evidence to conclude that X follows a Poisson distribution with mean average of 0.1 is not an appropriate model. X does not follow a Poisson distribution. This was example 1 of a goodness of fit test for specific distributions.